Greetings again, everyone. Here we have another interesting equation that we're going to solve. So in this equation, we're given to solve the value of x, where we have a half to the power of x is equal to x over 8. Now, this is a very interesting equation to solve, and as we go ahead into solving this equation, you may pause this video and see if you can solve this one by yourself. Also, check out my other Math Olympiad playlist to see how to solve other algebraic exponential equations. Now let us go ahead and look at our solution. Our equation is that 1/2 raised to the power of x is equal to x over 8. Now let us pause from here and see what we are looking at. We can try to solve this equation by guessing that x equals 2. Therefore, we would have 1 squared over 2 squared is equal to 2 over 8. 1 squared is just 1, and that's just 1 over 2 squared, and 2 squared is 4. So we have 1 over 4. And 2 over 8 is also equal to 1/4. So you can see here that this is a very simple equation to solve. However, not many can show working where x is actually equal to 2 without just guessing. So in this lesson, I will show you how to show all working that x is indeed equal to 2. So from here, we simplify our equation by having a half raised to the power of x. We will have this as follows. So we'll have 1 to the power of x over 2 to the power of x is equal to x over 8. Now we should already know by now that 1 raised to the power of any number will always equal to 1. So we just can rewrite this as 1 over 2 to the power of x is equal to x over 8. Now we move on to simplifying this equation by rewriting what we have. So we'll have 1 over 2 to the power of x is equal to x over 8. Then we multiply both sides of this equation by 2 to the power of x. And so in multiplying both sides of this equation by 2 to the power of x, we get 2 to the power of x over 2 to the power of x is equal to x over 8 times 2 to the power of x. We know that 2 to the power of x over 2 to the power of x is just 1 whole. So we can just cancel both top and bottom here and just have that being 1. So from here, that means we would have 1 is equal to x times 2 to the power of x over 8. And then we move on from here by multiplying both sides of this equation by 8. What this does is that on the left we would have 8 times 1, and on the right the 8's will be cancelled out. So from here we have 8 is equal to x times 2 power x. So now that we have simplified our equation in just one straight line, we will now solve this equation by using a special function. The name of this function is referred to as the Lambert W function. Now if you like this video so far, please remember to hit that like button and subscribe to my channel to see my latest math updates. This special kind of function is used to solve equation where the variable is both in the base and also in the exponent. And how this function also works is that it works on an expression as a times e to the power of a, where if we have this expression and apply a w function to this expression, the result is a. Now looking at this expression, we can look here where we see this x, this would be our first a, and here also in the power this will also be a. But what we don't have is our e. So we can write 2 in terms of e by saying, so we'd have 2 is equal to e to the power of ln 2. So what's essentially happening here is that we know that ln is natural log where the base is e. That ln will be cancelled with the base e here, and what will be left is this 2. So we'll be writing our equation with this understanding, rewriting 2 in the form of e. So 8 then is equal to x times, having this understanding, we change our 2, writing it in terms of e. So we'd have x times e to the power of ln 2, put that in brackets, and that's going to be raised to the power of x. Now according to our laws of indices, whenever we have a power in brackets raised to another power, such as a to the power of m in brackets raised to the power of n, this is the same as saying a to the power of m times n. So with this understanding, we rewrite our equation as follows. So we have 8 is equal to x times e to the power of, and we multiply our powers. So we have x times ln 2. Doing this, however, actually changes our expression from a times e to the power of a. So here we have x and here we have x ln 2 in the power. So we should have a in the base and also a also being in the power. So we have two different values here. Now we can quickly rectify this issue by multiplying both sides of this equation by ln 2. So from here we have 8 ln 2 is equal to, multiplying both sides by ln 2, we get x ln 2 times e to the power of x ln 2. And now having this equation, we can see where we have a in the base, so x ln 2, and in the power we have a again, so we have x ln 2. But at this time around we have our e in the middle. This means that we can now successfully apply our Lambert W function. So we'll take our equation, so we do both sides of this equation, so we put these expressions in brackets and we add our W function. Having our W function of this expression here gives us back the value of a, which is x ln 2. So we can rewrite what we have here on the left, so we'd have W of in brackets 8 ln 2 is equal to, and as we say, applying this W function, the value is just a. So we just write a, which is x ln 2. Now from here, we'll simplify what we have on the left and hence solving the value of x. So our equation is such that W of 8 ln 2 equals x ln 2. And as I said before, we simplify this expression here. So we can start by having our 8. So we know that 8 is 4 times 2. And since we are multiplying, our commutative property rule actually exists here. So we don't need to add any additional brackets. So we have 4 times 2 times ln 2. So we bracket this expression and we have this equal to x ln 2. So here we have this 2 times ln 2. Just taking it from there, we can apply this logarithm rule where we have a log b. So we have a log b. We can actually simplify this expression here. So this expression is the same as saying where we have log b, so we'd have take the log of b, and then this a that is multiplying this log b here becomes the power of b. So we can write any of our logarithm expression in this form. So in applying this rule here, we just rewrite what we have here. So we'd have w of, so we'd have 4 times log 2 or ln 2, which is going to be raised to the power of 2. So this 2 is going to be the power of this 2 here. And then we have this equal to x ln 2. And then from here we continue to solve x by simplifying what we have here on the left hand side of this equation. So we start by having w of, or we're going to take this 4. Now this 4, we're going to write it in the form of e. Just like what we did with the 2, we have this as e to the power of ln 4. And we're going to be having this times ln, which we know that ln 2 to the power of 2 is just going to be ln 4. And of course this is equal to x ln 2. Now let us actually rewrite what we have here on the left, and we are going to be changing the order. So we have w of ln 4, so we take ln 4 first, and we have this multiplying e to the power of ln 4, and this, as we say, is equal to x ln 2. Notice something interesting here. We have our w function being operating on an expression here where we have ln 4, which is a, we have our e, and we also have the power, we also have the same value, a. So we have a times e to the power of a, and we are applying our w function to this expression. Doing this, as we know, our result is just a, which is ln 4. So it is clear that we are going to have ln 4 is equal to x ln 2. Now we can simplify things a bit further. We know that 4 is a square number, so we can actually rewrite this as ln 2 squared. So ln 2 squared is equal to x ln 2. And applying our rule here that we looked at earlier, we can rewrite this equation as 2 times ln 2 is equal to x ln 2. And I'm sure you can actually finish this equation from here. So we solve x by dividing both sides by ln 2. So ln 2's will be cancelled out on the left and also on the right. So our final solution is clear. X is indeed equal to 2. And as we also proved that earlier in our video. Thanks again for staying tuned with me to the end of this video. I hope that this was very informative. Please remember to smash that like button, share and subscribe to my channel to see more of these kinds of videos. And until then, I'll see you again soon. Thanks again and take care.